Our next exercise is going to give us some practice with a mathematical operation that many of us probably haven't really used before, and that is the modulus operator. We're going to create a money changing application. One of the first of what I hope will be many applications that you'll find that could actually have some sort of practical use. As a matter of fact, as I've said before, if you've ever been to GetGo and you've ever noticed their little cash registers that they have, they're touchscreen computers, and when you give them cash and you are to be given change, the computer actually displays pictures of the amount, a picture of and the amount of each coin or bill you're due to receive as change. And so behind the scenes, the same process that we're going to put into this application is running to determine those counts to determine those counts that it displays on the computer. And so we're going to start off, as we do with every program, we're going to create a new project. We are going to, for the project name, is going to be capital M money, capital C changer, all lowercase, or all, I'm sorry, the M is capitalized and the C is capitalized. And that is going to be the same for we're going to use that same project name as the main class name. Now remember, the only thing that should be in that create main class name field is the word money changer, spelled out just like it is for the project. Make sure you don't have main dot or money changer dot main. You don't need that. Just the word money changer, please. When you've got all that in and you've selected the correct project location in order to make sure you save your program to your thumb drive so you can take it home, you might find it useful in the future. When you're finished with that, you can click Finish, and it's going to go ahead and create everything. Again, you can delete everything in gray. Those are comments, and you can put your own comments in. There's a sample set of comments in the in step 4 on page 83 of the handout, but I'm just going to do some simple ones. Once you've got your comments in, now we're going to create the variables that we're going to be using throughout this program. All of the variables that we will be using are going to be integers, and there's a reason for it, and you'll see as we build it. The first one is called cents, C-E-N-T-S, and we're going to set it equal to 393. The second one is called cents, capital L left, and we're going to set that equal to 0. And then one for dollars, quarters, dimes, nickels, and pennies. Each one of those variables will be set to 0. Dollars will eventually represent the number of dollar bills to be returned. Quarters, the number of quarters to be returned. Dimes will represent the number of dimes that will be returned. Nickels, the number of nickels. And pennies, the number of pennies. Now, the logic that we need here is kind of complex if we think about it. We've got to figure out the number of dollars to return, and then we've got to figure out the amount of change left after we give back all the dollars. Then, out of what's left, we have to figure out how many quarters are in there. Then we need to figure out what's left after we take all the quarters out. And so on and so forth. It's going to set us up for a pattern. But first, we're going to start with dollars. So, the number of dollars we're going to give back is going to be equal to cents divided by how many pennies are in a dollar? 100 pennies are in a dollar. Now you're probably thinking, wait, this is division. It's going to give me back, however many, it's going to give me back a decimal number. Or it could potentially give me back a decimal number, right? 393 divided by 100, going to move the decimal place over 2 spots, is going to be 393.93, right? Well, remember, what are we dividing here? We're dividing 2 integers. So we're only going to get a whole number as a result. Think about what dollars are defined as. Do we want to put 3.93 in there? Can dollars hold 3.93? No, it isn't. And since we are trying to figure out the number of dollars, the number of quarters, and quarters are a fractional amount of dollars, pennies are a fractional amount of dollars, dimes and nickels are also fractional amounts, the answer is no. We want integer division here. We really want integer division here to make this work. We can't give out parts of a dollar bill. The Treasury, despite the fact that yes, you can tear a dollar up, the Treasury Department and most places of commerce that you would conduct commercial transactions at do not like taking fractions of a dollar as ripped up bills. They're really not fond of that. They would prefer that you use coins. So we do want, and we can't break a quarter in half. We can't break, it's really hard to do without a setup, without tools. We don't want to do that. So first we're going to divide cents by 100. And that's going to tell us how many dollar bills, whole dollar bills we're going to give because of integer division. The next question we have to ask is, what's going to be left? How do we figure out what's left after we remove all of the dollars? Well, what tells us what remains? Modulus tells us what remains. So what we'll do here is we'll set cents left, which we'll now use from here on out. We'll set cents left equal to cents modulus 100. Because remember, after the whole dollars are removed, what's the remainder? What's left over? Right? If we take 100 divided by 393 in long division, the remainder is 93. That means the remainder is 93 cents. If we think about it in terms of dollars. If we think about it in terms of money. So what's the next smallest coin that we have? Quarters. So how do we find out how many quarters that we're going to give back? Did somebody say divide by 25? Okay. I didn't quite hear you, so I wanted to make sure I give credit where credit is due. Yes, we're going to take what's left over, which is stored in cents left. We're going to divide that by 25. And that's going to tell us how many whole quarters we're going to give. Because remember, we're doing integer division here. Now, how do we find out what's left after we take out all the quarters? Correct. Correct. And we're going to continue on with this, going down the road from largest coin to smallest coin. The next largest coin we have? Dimes. Do you see a pattern brewing here? Out of the value that cents left contains, we're going to divide by 10. That's going to tell us how many dimes we're going to get. And then to figure out what's left over after we give away all the dimes, we can find out what the remainder is once we divide by 10. Then we have nickels. And nickels are 5 cents, so we're going to divide by 5. And again, we're going to do modulus 5 to find out what remains after we give out all of the nickels. And so what's left? Pennies. Do we need to do any division or any modulus for pennies? The only thing that's going to be left are pennies. The last thing that we need to do, I'm sorry, do you have a question? Okay. The last thing that we're going to need to do is display the number of dollars, the number of quarters, the number of pennies, or the number of quarters, number of dimes, number of nickels, number of pennies. I keep thinking of an old cartoon I used to watch called DuckTales. Way back in the late 80s, early 90s, and the mermaids. Quarters, pennies, nickels, and dimes come to us while there's still time. So that's why I always say it, quarters, pennies, nickels, and dimes. So I'm sorry if I get those mixed up, but I probably watched that episode as a child on reruns 500 times. So it's kind of stuck in my head. All right, so now I'm going to start creating all of the statements to print out. The first thing I'm going to do is display the total change. And then I'm going to start displaying the number of each item. I'll give you guys a few minutes to make sure everybody's caught up before we do anything else. All right, let's take a look at this program. I'm going to step through it line by line with you as we go so that we can see how it functions and how the different statements work with the sort of running total that we're running in sense left. And we can see how the math works out. All right, so the first thing we do as we wrote the program, we created a number of variables. The first one is sense, and it creates so the first variable created is sense, and we assign the value 393. 393 cents we have to give back. We set cents left equal to 0. We create dollars and set it equal to 0. We create quarters and set it equal to 0. We create dimes and set it equal to 0. Same with nickels and same with pennies. And these are all integers. Then, now we start figuring out how much of what are we going to give back. So we take 393, divide it by 100, and that's going to tell us how many dollars we've got. And because we're dividing integer by integer, the result's going to be an integer. And we're just going to lop off, we don't even round up, we lop off the decimal value. So the result is going to be $3. And you can see here, here's our variable dollars, here's its current value of 3. Then we're going to take cents left, and we're going to say, give me the remainder of cents once I divide by 100. Now we know that 393 divided by 100 would give us 3.93. In this case, cents left is going to be 93 cents, and you can see that right here. Now we're going to take cents left and divide by 25. That's going to give us the number of quarters that we're supposed to give back. And you will see that we're supposed to give back 3 quarters, so 75 cents in quarters. Now, when we do the modulus, we'll discover that that leaves us with 18 cents, doesn't it? 75 plus 18 equals 93. So now we got to figure out how many dimes are in 18 cents. We're going to, again, do division. And it gives us 1. 10 goes into 18 one time. Now we got to find out what's left. And what's left should be 8. And we're going to, again, we use the modulus to figure out what's left. Cents left is now 8. So now we got to figure out how many nickels in 8 cents. We'll use division again, and we'll discover that we give back 1 nickel. To figure out what's left, we're going to use the modulus operator to get what's left after we take 5 from 8. And what's left is 3 cents. Our next smallest coin is a penny. That's every penny is 1 cent. So we just assign that to pennies. So we're going to give back $3, 3 quarters, 1 dime, 1 nickel, 1 penny. Or 3 pennies, sorry. And so now we're going to print all of that information out. We're going to print out the string, the total cents of change, space, that's a literal string. We're going to display it, we're going to print it out or display it exactly as it's written, plus is concatenation, and then the value of our variable cents. So our statement is going to be the total cents of change, 393. And then we're going to print out the string, the dollars are, and the value of dollars, which is 3. Then we're going to print out the quarters are, and the value of quarters are 3. And then we're going to print out the string, the dimes are, and the value of dimes, which is 1. Then we're going to print out the nickels are, and the value of nickels, which is 1. And then we're going to print out the pennies are, and the value of the pennies, which is 3. Does that make sense? Questions? Yes? It's a \T, and I would put it, instead of the space, I would put it inside the quotes. I would get rid of the space and put it right after the last word. I don't know that that's going to work to line everything up, but that would be the starting place I would go, and then I would add additional spaces to make everything line up, because the tab's going to be 5 spaces from the end, and since the ends all don't line up, they're not all going to line up. You're going to see they're a little bit all over the place here. So what you're going to have to do is figure out then how many tabs and how many spaces you need to get everything perfectly lined. And while I know people like it because it's neat, it can become an exercise in futility. Let's try that. Whoops. So like for the first line, you need two tabs and like 2 spaces to get it to line up. For the second line, you're probably going to need 2 tabs. /T is tab. Again, \T is tab. You're going to need like a tab in 1 space. Okay? And that's going to be a lot of trial and error to make it look that way, if you really want to line them all up. That's why I don't really make you guys do that. because it can be a lot of work. And it can be very frustrating because you got to put it in, you got to run the program, make sure it looks the way you want. If it doesn't, make the adjustments, run it again, make the adjustments, run it again. This is the bad part to developing GUI applications in Java the way we're going to, is because like Visual Studio, the nice thing about Microsoft tools, they give you a visual environment to work in, so you drag and drop all the like the window and the buttons and the text fields and everything. Java has tools for that, but none that we're going to be able to use. So it's kind of a pain. Yes? The pluses or the... Oh, yes. Yeah, that'll work too. That'll work too. Inside, yes, inside a literal string. Now, it could be a literal string that says nothing but /t, but it has to be inside the quotes in order for it to work. That's the way the Java special characters work. Any other questions on this? Oh, don't think we're done. I have more up my sleeve for just such an occasion. Yes. You're in insert mode. So on the keyboard, you'll see an insert key in the middle. Click it again. You're now in regular. You're actually in insert mode. You were in overwrite mode. Not a problem. Any other questions? All right, I got another set of handouts coming around. This is sort of my spare